Welcome back to the deep dive. Today we're getting really focused on one specific piece of hardware.
We are. It's the NTI ST-C5V2ARS-L-1000SP, a high-res VGA transmitter.
So let's, set the stage. This device is all about extending legacy KVM access to a PC.
KVM, so keyboard, video, and mouse.
Right. But it pushes that signal, and this is the really wild part, up to an unbelievable 1,000 feet.
It's easy to forget how hard that is.
Right.
Not long ago, that would have required these huge, expensive coaxial cables.
Exactly. And the whole point here is that it uses common infrastructure. We're talking standard CT5 or CT6 cable.
Right, the stuff that's probably already in your walls. And that's where the real engineering challenge comes in, maintaining a perfect signal, especially for high-res video, over that distance.
Okay, so let's unpack that. What exactly is it sending down that cable?
Well, it's the legacy stuff. PS2 for keyboard and mouse, VGA video, but also two-way audio and even optional RS232 control.
And the compatibility is interesting. It's not just, Windows 10.
No, and that's a huge clue. It lists support for things like Solaris, Linux, FreeBSD, even older Mac OS versions.
So that tells you its purpose, right? It's designed for these specialized, maybe older enterprise systems that are absolutely mission critical.
Precisely, the kind of systems you can't just unplug.
But let's talk about the spec that really jumps out, the resolution. We aren't talking about some fuzzy standard def image here.
Not at all. The sources say it supports up to 2048 by 1536. That is an incredibly sharp picture.
So how does it keep that image clean? I mean, pushing that much data over hundreds of feet of copper Ethernet cable seems like a recipe for disaster.
It is, and the secret is all in the automated microcorrection.
Microcorrection.
Yeah, the unit is actively monitoring and adjusting the video quality, and crucially, something called color skew. It fine-tunes the timing to keep everything sharp.
And how fine are we talking?
We're talking a maximum delay adjustment of 62 nanoseconds.
That's insane precision.
It is, and it's adjustable in these tiny 2-nanosecond steps. And the best part, for any tech who has to install this,
it remembers the settings.
It stores them automatically right on the device, even if you lose power. You set it once for that specific cable run, and you're done.
That kind of engineering is so important because there's always a trade-off, isn't there? Distance versus quality.
Always. It's a fundamental physics problem.
I was looking at the distance table, and if you want that maximum 1,000 feet, your resolution is capped at 1920 by 1200.
Right.
But if you absolutely need that top-tier 2048 by 2036 resolution, your maximum range suddenly drops to just 600 feet on standard UTP cables.
And that's the compromise you have to make. But it's not just about the signal. The physical unit itself tells a story.
And it's built like a tank, I saw that. Rugged steel construction.
Rugged steel, and critically, it's TAA compliant.
Ah, the Trade Agreements Act. So that points directly to its intended environment, doesn't it?
It's a dead giveaway. TAA compliance is often a requirement for U.S. government, defense, or other highly regulated contracts.
So these are for places that need secure, durable, high-res remote access. So if we boil it all down, the real takeaway here is how this one specialized tool uses those tiny nanosecond adjustments to solve a huge logistical problem.
It really is. It bridges this high-end technical demand with simple, ubiquitous network cable that's everywhere.
Pushing crystal clear video up to 1,000 feet. It's just impressive stuff.
Which leaves us with one final and I think important question for you to think about. It's about the cable itself. The specs are radically different for UTP unshielded twisted pair versus STP, which is shielded.
Right, the performance isn't the same.
Not at all. In fact, to hit that peak resolution, you actually get more distance on an unshielded cable than a shielded one, which feels counterintuitive.
So the final thought is, what do you invest in? The cable that gives you the absolute maximum distance or the one that gives you better protection from electrical noise?
It's a crucial design decision. And it proves that even with smart hardware doing the heavy lifting, the physical infrastructure still matters a lot.